Hi, today we are going to solve GATE Chemistry 2021 question number 28. The shapes of the compounds ClF3, XeOF2, N3- and XeO3F2 respectively are. Four options are given. Let us solve this question. In order to answer this question, we should have an idea about valence shell electron pair repulsion theory. This theory tells that the atoms in a molecule tries to stay as far as possible in order to minimize the repulsion and thus to achieve maximum stability. This theory helps us to predict the geometry and shape of the molecule from calculating the total number of electron pair in a molecule. This table will act as a guideline. For example, if the number of electron pair calculated is 3, the corresponding geometry will be trigonal planar and the shape can be either trigonal planar or bent depending on whether lone pair is present or not in that particular molecule. The calculation of total electron pair is very easy. Let us start from the first option given, that is ClF3. In this molecule, Cl is our central atom. We know Cl is in halogen group and has 7 valence electrons. The side atom given here is fluorine. Each fluorine requires 1 electron to complete its octet, and since 3 fluorine atoms are there, the total electrons provided by the side atoms are 3. Therefore, the total number of electrons around ClF3 molecule will be 7 plus 3, that equal to 10, and hence the total number of bonds will be 10 by 2 equal to 5. As we have seen in the table given in the previous slide, if total bonds is 5 or total electron count is 10, the geometry will be trigonal bipyramidal. Now the shape. In ClF3 there are 3 fluorine atoms and hence there will be 3 ClF bond pairs. The remaining 5 minus 3, that equal to 2, will be lone pairs. Now the question arises is that where will the lone pair be located in the trigonal bipyramidal structure? This is trigonal bipyramidal structure. We have 3 equatorial and 2 axial position. Imagine 3 equatorial position as a triangle. Hence the angle between them will be 120 degree each. Now the angle between 2 axial position which stays above and below the triangle will be 180 degree. And the angle between one axial and one equatorial will be 90 degree. There are 3 different arrangements that is possible for the given molecule ClF3 in the trigonal bipyramidal geometry. The 2 lone pairs can both be at axial position as shown here, or both be at equatorial position, or one be at axial and one at equatorial position. Now, which one is more preferable? In order to find that, we should know a simple rule, that is, lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. Let us find out the angle between each. The maximum the angle farther the lone pairs or the lone pair bond pair is situated, and hence lesser the repulsion, maximum the stability. In first case, the lone pair is situated both at axial and hence at 180 degree each. And in the second case, lone pair is situated at the equatorial and at 120 degree, and in third, one axial equatorial means at 90 degree. Now we have to also consider lone pair bond pair repulsion. In the first case, there are 3 lone pair bond pair which are situated at 90 degree. In the second structure, there are 2 lone pair bond pair which are situated at 90 degree, and in third case, there are 3 lone pair bond pair. So, we can Eliminate the third option in which both lone pair is situated at 90° and 3 lone pair bond pair repulsion is present at 90°. Now, among the first two options, since the first option has 3 repulsion at 90°, the second one is more favorable and hence the shape will be T shape. The next one is XeOF2. The number of valence electrons on xenon equal to 8 and the number of electrons required by the side atoms each fluorine equal to 1, giving a total of 2, and oxygen needs 2 electrons to complete its octet, and hence the total number of electrons on XeOF2 will be 8 from the xenon, 1, 2 from 2 fluorine atoms and 2 from oxygen will be equal to 12. And hence the number of electron pairs will be 6. Oxygen will have 1 double bond and among 6 only 5 position has to be considered, giving the geometry of trigonal bipyramidal, and this molecule also has 2 lone pairs. As we discussed in the case of ClF3, XeOF2 will also give a T shape. Next is N3- or azide. In this particular molecule, we cannot differentiate side and central atom. Hence, let us approach in a different way. Let us calculate the total number of electrons considering all nitrogen as the central atom. Hence, we have 3 nitrogen giving 3 into 5, that is 15 electron. This molecule has 1 negative charge, thus giving a total of 16 electrons. Now let us distribute these 16 electrons around 3 nitrogen so that each nitrogen has a completed octet and hence is stable. Let us start by giving 1 bond each, that is N single bond N single bond N. 4 electrons are used. Remaining 12 electrons are there. Let us draw double bonds in between nitrogens. N double bond N double bond N. Now the central nitrogen has got its octet completed. The remaining 8 electrons can be distributed among the 2 nitrogen so that the octet is completed. Hence we have the structure like this. These 2 nitrogen around the central nitrogen atom will try to stay as far apart as possible to minimize the repulsion and hence will stay at 180° to each other, giving a linear shape. The next one is XeO3F2. Here the central atom xenon has 8 valence electrons. The number of electrons required by the side atom total 2 fluorine and oxygen total 3 oxygen, giving 2 into 3 equal to 6 electron, and hence the total number of electrons in XeO3F2 will be 8 plus 6 plus 2, that equal to 16. The number of electron bonds will be 16 by 2 equal to 8. Each oxygen will have a double bond and hence since 3 oxygen is present, 3 double bonds will be there. Hence only 8 minus 3, that equal to 5 positions are available. 5 means the geometry will be trigonal bipyramidal. And since there are no lone pairs present, the shape will be trigonal bipyramidal. Now the answer to the question, the shapes of the compounds ClF3, XeOF2, N3- and XeO3F2 respectively are T-shape, T-shape, linear and trigonal bipyramidal. For further reference, you can visit classes of Professor M.S. Balakrishna in NPTEL and the YouTube link is given below.